video, I will be showing you what are subnets, how they work, and how you can manage them more easily using Python. As you can see here, I have this imaginary network. Every computer must have a different IP address if it wants to communicate with other computers, like accessing the internet. It's like the numbers on our houses. They must all be different. For every IP address, the computer interprets them in binary form. So over here you see them in decimal form, but in binary, the computer will take in each chunk and find its binary form in 8 bits. So if we have a chunk that's 255, that would be 1, 1, 1, 1, 1, 1, 1, 1. There'll be 8 ones. Now, let's see here. The server sends internet to this router, and the router distributes the internet between switch 1, switch 2, and switch 3. Over here you can see we have our subnet in this circle where these computers share one part of an IP address. Here we have 192.168.2, and then the other part will be changed. This 24 means that in the subnet, you can see this is 8, and then add this will be 16, add this will be 24 bits. There will be 8 more bits that we can change around and distribute to different computers. Over here we have a larger subnet. You can see this is /16. It means that here we have 8 bits, here we have 16 bits. So the first 16 bits of the IP addresses of the computers in this subnet will be the same. There will be 16 more bits that can be changed around to give to different computers. You can see that nowadays there are hundreds and hundreds of computers around, and IP addresses are running out. There's a total of 2 to the 32th power IP addresses for 32 bits. Now, exactly what is binary? Binary is a system of tiny switches inside a computer that a computer turns on and off to give us whatever we see on a computer. And when a switch is on, we will see them as a 1 in binary digits, and when a switch is off, we will see it as a 0. So, if you see 0, 0, 1, that will mean that 1 switch is on and 2 switches are off. I have my IP address here, 192.168.1.8. Here is how we can represent these numbers in binary. In decimal, which we are all familiar with, like 1, 2, 3, when you can see when these switches are all off, so they are all 0, and this will also be 0 in decimal. When this switch is turned on, we get a value 1, and in decimal it is also 1. But what if the position is changed? What if this switch is turned on so that this is 1 and the rest are 0? In decimal we know it's a 10, but in binary we get a 2. Why is that? Well, in a computer, the switches can be turned on and off, so we get 2 choices for each of them. When we can see that this switch here is actually 2 to the 0's power. This switch here will give us 2 to the 1's power. This is a value 2 square. This is 2 cubic. This is 2 to the 4th power. It's just like decimal, only that in decimal, this is 10 to the 0's power. So if this is 1, 10 to the 0's power equals to 1. If this is on, here we get 10 to the 1's power, so we get 10. What if this one is on? We get 10 square, so this is 100. If this is on, it's 10 cubic. So in binary, we just substitute the 10s into 2's. So you can see, if the network address of an IP address is different, a computer will know that IP address does not belong in our network. So it will ignore it and only work on the ones with the same network address. Over here, I have an example for my network. Let's say our network is 10.1.0.0/16. So /16 means that our subnet mask will have 16 ones in binary form followed by 16 zeros. And in decimal form, we get 255.255.0.0. Here I have computer A's IP address in binary form, and we convert it into decimal form. Here we get this here. Computer B's IP address is over here in binary form, and computer B's address is over here in decimal form. With this subnet mask, we can separate the network ID, or should I say the network address, and the host address from our IP addresses. So you can see it's the first 16 digits. So we check. The first 16 digits of computer B is over here. This is the first 16 digit of computer A. You can see that they match. So computer A and computer B belong in the same subnet. Here we have the host ID, and obviously they're different. So the total amount of hosts for our network here will be 2 to the 16th power. So there are 2 to the 16th power available variations for switching on and off of our host ID here. So the binary numbers can be switched on and off in a total of 2 to the 16th power different amount of ways. And the value is 65,536. Now, we have a network ID that is here with the host ID being all zeros. Our broadcast ID is, here we have our network ID, and in decimal form our network ID is 10.1, and the broadcast will be the last one, so it's the host ID being all ones. So you see 255.255. So the total amount of available hosts is the total amount of hosts subtract 2 for the network and broadcast, and we get 65,534. Now let's have a look at how we can easily find this information using Python. First, I import the module ipcalc. It may not come built in, so you may have to install it. Now, in a for loop, for every, let's see, IP in ipcalc.network, in these brackets I can pass in our previous IP address over here. 192.168.1.8/24. So for every IP in this here, I want to print the string of that IP. Here we get a long list of a long list of IP addresses, you can see the hosts are all different. The host address. So I have /24. So only this chunk will change. The rest, which is the network address, will stay the same. So you can see here, these are a total amount. Now, this is a IPv4 address. We can also use Python to get us all the hosts for an IPv6 IP address. And before that, let me just print out the subnet mask for this IP here. Let's see. I'll print. Let's see. I'll copy this. Let me store this in a variable. Let's say subnet. Now I can print the string of subnet dot net mask. So this is subnet mask. Let's see here. Oops. There is no S there. So it's just net mask. We get this is the subnet mask for our network here. Now let me just have a different network. Let's say this equals to, instead of /24, we will have /19. Now if we print this again, we get this is our subnet mask. And now let's have a look at IPv6 IPs. So IPv6 will give us 8 chunks instead of 4. And inside, we will have characters too. So it's not just numbers. We'll get A to F. So it's like we'll have hexadecimals instead of simply these numbers. Let's say, I'll just copy this again. If we want an IPv6, we have to change these dots to colons just so Python can differentiate between them. Now, I'll add, we can have characters from A to F. And instead of /24, we can have /59. Now I want to print the subnet mask of that subnet, which is now an IPv6. Here we get our subnet mask. So if we convert this from hexadecimal to decimal, the F is actually a, let's see, and A is a 10, B is 11, C is 12, D is 13, E is 14, and F is 15. And I'll just quickly, for every character in, subnet, print that character, the string of that character. You can see we get a lot of these. Each time we will get characters. This is the end of this tutorial. If you have any questions, requests, suggestions, or comments, please leave them down in the comment sections below. Please subscribe to my channel. It's called NetsEDU. Today is February 23rd, 2020. Please hit the thumbs up button if you enjoyed this video.